Okay, so today we're going to talk about how to name and write formulas for acids. We've already done ionic compounds and molecular compounds, so today is the last one about acids. So let's go back to our first page one more time and look at what makes an acid be an acid. Because the first thing you do before you go and write a formula or a name is you decide what type of compound you have. There's three main types: ionic, which has a metal and some nonmetals, but the metal will be first. Molecular compounds are only nonmetals. And finally, for the acids, they're going to have hydrogen first. They are made up of a hydrogen ion with a group of nonmetals. So you're always looking for that hydrogen first. Okay. Alright, so here are the rules when we name acids. The name goes by what comes after the H, because they all have H first. So if the anion, the negative part, because hydrogen would be the positive part, then the negative part ends in "ide", and you put hydro in front, and you change "ide" to "ic", and then you add the word acid. If the negative ion, the anion, ends in "ite", then you change "ite" to "us". And finally, if it ends in "ate", the anion ends in "ate", then you change "ate" to "ic", and add the word acid. Okay, and I'm going to write down a good way to help you remember, especially these two. Okay? Okay, that's just a silly way that I tell the kids to help them remember. If I bite you, you would cuss. "Ite" becomes "us." And if you ate it, you would be sick. "Ate" becomes "ic". Okay, so here's some examples. HCl, well, we know it's an acid because it has hydrogen first. And then Cl would be called chloride as an ion. So we follow the "ide" rule, right? Chloride, the "ide" rule. So, again, we don't name the hydrogen. We look at the anion. Chloride becomes chloric, and then you put hydro in front. Hydrochloric acid. Okay? Then the next example, if you look at H2SO3, SO3 is our anion, and it's called sulfite. Again, you'd find the name for that on the back of your periodic table that I gave you at the beginning of the year. It has a list of all the ions that you'll need to know for the test. Okay? So SO3 is called sulfite. So if I bite you, you would cuss. Sulfurous. Notice that the middle syllable, the UR, has been added back. Okay, and then finally our third example, HNO3. Again, we look at just what's behind the H. That's how we name it. NO3 is called nitrate. So now we're using the H rule. So nitrate becomes nitric. Okay, so I'm going to pause the video, or you should pause the video, and try these on your own. Okay? And when you come back, push play, and I'll have the answers here, and you can check them. Okay, so here they are. Check your answers. First, I wrote down the name of the anion, the negative part, which is everything that comes after the hydrogen. That's what you would look up on the back of your periodic table. So sulfate ends in ate. You use the ate rule. It becomes it. But for phosphorus and for sulfur, you do put back in that middle syllable. So not sulfic, but sulfuric acid. And then fluoride, F is fluoride. You follow the ide rule, and that's the only one where you put hydro in front. So hydrofluoric acid. Carbonate becomes carbonic acid. Perchlorate becomes perchloric acid. Chlorate, chloric. Chlorite, chlorus. If I bite you, you would cuss. And hypochlorite is hypochlorous acid. Okay, then if you notice it says, what about these acids right here? And they're not on the back of your periodic table, but it tells you that it's the same as your chlorate series, which is right here. So the highest oxygen is called perchlorate. So the highest oxygen for this one, which has just been substituted with bromine instead of chlorine, would be perbromate. And then the acid would be perbromic. So I'm not going to write all of these down, but you should just know that it's similar to the chlorate series, right? So this would be bromate, so it becomes bromic acid. This is bromite, so bromous acid. And this is hypobromite, so it's hypobromous acid. And the same for the iodate series. Okay, it follows the same pattern. Alright, so remember that because they're not on the back of your periodic table, but you still have to know how to name them. Okay, now we're going to write formulas and names. We already did names, but let's try writing formulas. And it's really no different than writing a formula for an ionic compound. We do crisscross of their charges, except when it's an acid, we know that always your hydrogen ion is first. So I'm going to write hydrogens all the way down here, and each one of them is a +1 ion. Okay, so for this one, we have a +1 for the hydrogen and a -1 for NO2. So to get the formula, you crisscross, just like we do for ionic compounds. And it's just a 1-to-1 ratio. We don't write the ones. So HNO2 is our formula. Okay, then we want to try to name it as well. So remember, we don't name it according to the hydrogen. They all have hydrogen. You look at what comes after the hydrogen. NO2 is called nitrite. So we follow the ite rule. If I bite you, you will cuss. So nitrite becomes nitrous. Okay, so then the next one, again, since it's telling you to make acids out of these, then that means you're going to have a hydrogen ion combined with that negative ion that's listed. And again, it's just a 1-to-1 ratio, 1 plus to 1 minus, so you just put the two together, H and then BrO4. Okay, and then we're going to try to name it. Again, don't name the H. You only name, or you go off of the name of the negative ion. And BrO4 is like ClO4, which was perchlorate. And so this one is perbromate, so it becomes perbromic acid. so I'm going to go a little faster on these now. Again, you just have a 1-to-1 ratio, so let's just put them together. And this follows the chlorate series again, so keep that in mind when you're trying to name it. Okay, so far the acids have just been in a 1-to-1 ratio, but this one is not. It's going to be different because the sulfide ion has a -2 charge. So if I bring that down and across, and that down and across, then now we get H2S. Okay, and then we name it according to what's after the H. So that's called sulfide, so we follow the ide rule. Okay, then the next one, again, is just a +1 and a -1, so the formula is pretty easy. Put them together, and then think about what the negative ion is called. CN is called cyanide, so we're following the ide rule, even though it's a polyatomic ion. So we put hydro in front and change I to ic. Okay, so that one would be hydrocyanic acid. And then finally, we have H and OH in a 1-to-1 ratio. HOH. Okay? Now, you probably recognize that there's 2 H's and there's 1 O, so you know this better as H2O, which we call water. And everyone should know that's water. But there's more than one name for that because it is made up of a positive hydrogen ion and a negative hydroxide ion. So if we're naming it according to the acid way, then let's think about we have OH, which just ends in ide. It's called hydroxide. So we're going to follow the ide rule and put hydro in front and change I to ic. Okay, so that would be hydrohydroxic acid, which is a way to name that. You know it better as water, but it could be called hydrohydroxic acid. It also could be named according to a molecular compound. Sometimes you might see it as dihydrogen monoxide. All right, but they're still basically just water. Okay, on this page, there is a list of acids that are common. You find them in everyday items. We eat a lot of these acids. And so we just want you to memorize them. I mean, you can always follow the rules to name them, but since these are the most common acids that you'll see, it would be a good idea to just go ahead and memorize them so you can come up with their names more quickly. So I'm going to just list their names, and you copy them down and make sure you know their names. So one final thing to do for me tonight, and then make sure you show me that you did it when you come to class the next day. There is a practice worksheet. If you flip towards the back of your notes and find the one called Naming Acids right here. We're going to do this page and the page right here, but for you it's all on one page. Alright, so what I want you to do is pause the video, give these a try. Once you're done, push play again and check your answers. Okay, here they are. Check your answers. And also I put over here the 3 main rules, the shortcut version, to help you figure out where these names are coming from. Okay? Then now on the bottom half of this page, you have the names, and so we want you to write the formulas. Remember, when it's an acid, what always comes first is hydrogen. So give these a try, pause your video, give these a try, and then push play again so you can check your answers. Okay, here are your answers. Check them over, make any corrections if you need to. Over here, if I saw that it ended with ic, then I remembered that that came from 8, and so I wrote down sulfate and its charge, and then you crisscross their charges to get to the formula. So that 2 comes down and across with the H, H2SO4. So check over the rest of your answers, and before we end this, I want to go back and look at our periodic table. Okay, so how do you tell metals from non-metals? That is one of the key things you need to know in this unit in order to correctly write formulas and write names. You have to know metals from non-metals. So remember, that's the stair-step line that goes right here. Alright, and then to this side is your metals. And all of this portion right here are your non-metals. Okay, So remember the trend for the charges as well, especially if you're in pre-AP, because you will have to know those from memory. Grade level, it will help you to know the trends, because otherwise you're going to be spending too much time looking up the charges, and you will run out of time when it comes time for you to take the test. Okay, you have only 45 minutes to finish the test. So you do need to already know the charges for some of these ions. And if you know the trend, which is pretty easy to remember, then that'll help you a lot and cut down on time. Okay, that concludes our lesson.